All right, listeners, ready for another deep dive. Today we're taking a close look at Atlas, a novel pathology foundation model. It's from the folks over at Mayo Clinic, Charite, and Ignostics.
Oh, yeah, this one really caught my eye too. Big implications for machine learning and healthcare as a whole.
Definitely. So this paper is all about Atlas, this new AI. It's trained on a seriously massive data set. We're talking over 1.2 million histopathology images.
Histopathology images, for anyone just joining us, are those images of tissue samples, like what pathologists look at under the microscope.
Right, and this is where Atlas comes in. The paper shows it actually beating out other top AI models on a whole bunch of benchmark data sets, 21 to be exact.
And that's the crazy part. It's not even the biggest model out there.
Exactly. It's super efficient. You know, maybe we could even start running these analyses right in a doctor's office someday.
That would be a game changer. But first, how about we break down how Atlas works?
Yeah, let's do that. So at its heart, it's a VIT H14 model. It's just a type of model that's really good at picking up on subtle patterns, like those tiny variations in cells that could mean something's wrong.
Oh, I see it. Okay.
And remember, it's trained on that huge data set of 1.2 million images from both Mayo Clinic and Charite.
One thing that stood out to me was the variety of staining types they used. It wasn't just your typical H&E staining. They included IHC and even special stains.
So it's like they taught it to read tissue in multiple languages.
Precisely. And get this, it was also trained on images at different magnifications, just like a pathologist would zoom in and out with a microscope.
Ah, that's clever. So it's not just about recognizing patterns, it's about recognizing them at different scales.
And that's really important for real-world pathology, right?
Yeah.
Things look different depending on how zoomed in you are.
Absolutely. And this kind of brings us to the whole idea of why foundation models like Atlas are such a big deal in AI.
Yeah, it's a whole different ballgame than traditional models.
Right, those older models were kind of like specialists, really good at one specific task. But foundation models, they're trained on tons and tons of data, all sorts of data. And that lets them learn and adapt in ways we never thought possible.
Like a Swiss Army knife for AI.
Exactly. And that's perfect for something like pathology, where you've got so much variety, different tissues, different staining methods, and all kinds of tasks, diagnosing diseases, predicting how someone might respond to treatment. It's a lot.
So instead of building a separate AI for each little thing, you have this one powerful model you can fine-tune for whatever you need.
So much more efficient. Okay, well, there are a few specific details in the paper that I thought were really interesting. For one, Atlas scored an average performance of 61.9% across all those benchmark data sets.
That's over a full percentage point higher than the next best model. That's huge.
And wasn't just good overall. When you look closer, Atlas did incredibly well on both morphology tasks, like spotting specific cell types, but also molecular tasks, like predicting biomarkers.
It's like it's good at everything, showing off its range.
And remember how we were talking about efficiency before? Well, the paper shows Atlas actually beating out models that were way bigger and trained on even more data.
Yeah, that's impressive. It shows that bigger isn't always better. Sometimes it's about how you train the model.
Totally. Oh, and they mentioned something called the Rudolph V training paradigm, but they didn't really explain it.
Maybe it's something they've published before. Definitely worth looking into for anyone who's curious.
Definitely. Oh, and there's this one graphic in the paper comparing Atlas to some other top models.
Yeah, it really makes you visualize how well it stacks up. Even though it's not the biggest or the most complex, it still comes out on top.
Right. It really drives home the point that this is something special. But even beyond all the technical stuff, what's really exciting is what this could mean for patients.
Absolutely. Imagine if AI could analyze tissue samples super quickly and accurately. We could diagnose diseases earlier, personalize treatments. The possibilities are incredible.
It's a future where AI isn't just some research project. It's a vital part of how we deliver healthcare, improving outcomes, and maybe even saving lives.
Now, that's something worth striving for. It's amazing to think how far we've come with AI and pathology,
Yeah, looking back, it's crazy how much progress has been made.
It really has. And for those just tuning in, the path to something like Atlas has been a wild ride.
Oh, absolutely. So early on, when people tried to automate things like cell counting, they were stuck trying to program specific rules into computers. Basically, they were trying to teach a computer to recognize patterns by spelling out every single detail.
Like writing a super detailed guide to recognizing birds just from their feathers.
Yeah, it was a nightmare, especially with how complex and varied those pathology images are. And that's where machine learning came in, right? Instead of all that programming, we started training algorithms on giant data sets.
So we stopped giving the computer a bunch of rules and just started feeding it examples, letting it figure out the patterns on its own.
Like teaching a kid about animals with flashcards instead of a textbook.
That's a great analogy. And then, of course, deep learning came along with those crazy neural networks and things really took off.
Deep learning is so good at image recognition, and it really started to make a difference in pathology. People were using it to find cancer cells, classify different types of tissue, even predict how a patient might do.
And the more data we got, the better these models became. Data is like the fuel for these AI engines.
Totally. And we can't forget about convolutional neural networks, or CNNs. Those were a total game changer.
CNNs were designed specifically for analyzing visual data, like highly specialized pattern detectors.
Yeah, they were a huge deal for all sorts of pathology applications. And they paved the way for even more advanced models, leading us to the foundation models we have today.
Like Atlas, it's not just a random breakthrough. It's the result of years and years of research and innovation.
Totally. The paper actually talks about some of the challenges and what's next for the field. They really emphasize the need for even more diverse benchmark data sets.
Oh yeah, that's important. We need to test these AI models on all kinds of data that truly reflects the real world.
Right, like training an Olympic athlete in all sorts of weather and on different surfaces. You want them ready for anything.
Exactly. And that brings up another point the authors made. We need these AI models to be transparent and explainable.
Especially in healthcare. It's not enough to just know what the AI is predicting. We have to understand how it got there.
We don't want some black box spitting out answers. We need to be able to peek inside and see the logic behind those answers.
Otherwise, how can we trust what it's telling us? Building that trust requires transparency and explanations. Doctors and patients need to understand why the AI recommends a certain diagnosis or treatment.
For sure. And the more we use these models in healthcare, the more important that explainability will become. It's a hot research topic for a reason.
It really is.
Yeah.
But even with these challenges, there's so much potential for where this technology could take us. What if instead of just analyzing still images, we could use AI to analyze live video feeds during surgery?
Oh, wow, that's interesting. So the AI could be looking at the surgical field in real time and pointing out things the surgeon might need to pay attention to.
Yeah, like an AI assistant with supervision working right alongside the surgeon. And it's not just about having an extra set of eyes. It's about the AI processing all that data and maybe even predicting complications before they happen.
That would be huge for surgery. More precise procedures, faster recovery times. Patients would benefit so much. But that's not even the limit of what we could do.
Now I'm really curious, what else is out there?
Well, just imagine if we push the boundaries even further. What if, instead of just analyzing tissue, we could use AI to design new tissue?
Wait, what? You're talking about using AI to basically become biological architects, designing tissues and organs from scratch.
Exactly. We feed the AI everything we know about tissues, how cells interact, how organs develop, and it spits out blueprints for new tissues perfectly tailored to a patient's needs.
That's wild.
Right.
We could create tissues for transplants that wouldn't be rejected by the body.
It would completely change regenerative medicine. Imagine the possibilities for treating diseases and injuries.
And remember those diverse data sets we were talking about?
You're thinking we could use AI to make synthetic tissues to test and validate these models? It would take research to a whole new level.
Exactly. AI helping us develop even better AI. It's crazy to think how these ideas, which seem like sci-fi right now, could actually happen in the not-too-distant future.
And speaking of pushing boundaries, it's time for novel notions.
It really makes you think about what's possible, right? When you look back at where we started, it's incredible. From those basic rule-based systems to these amazing deep learning models, it's been quite a journey.
Yeah, it shows that AI isn't about replacing us, It's about giving us better tools, helping us do even more.
Exactly. Like with Alice, it's not designed to replace pathologists. It's designed to help them be even better. See things they might miss, make faster decisions.
It's all about working together, combining the power of human intelligence and artificial intelligence.
To create something truly amazing. And that's a really important point to remember as we explore AI in healthcare and beyond. It's about finding ways to collaborate, to learn from each other, to build a future where technology helps us solve the biggest problems we face.
Well said. This has been a great deep dive into Atlas and foundation models. We've covered so much ground. from how the model actually works to what it might mean for the future of pathology.
And we even got to explore some pretty wild ideas and novel notions, thinking about what might be possible if we really push the limits.
And for anyone who wants to learn more, you can find the full paper on Atlas linked in the show notes.
Definitely check it out. It's a fascinating read. Until next time, everyone, keep exploring, keep asking questions, and keep pushing the limits of what's possible.
Happy researching!